Hey Lake Hazel Middle School. Today our lesson is on dividing fractions. This one is going to be a little bit different from the ones that we've done so far on adding, subtracting, and multiplying. We're actually going to start with the algorithm and then we're going to talk about why that algorithm works and what makes it possible. So our first division problem for today is 2/3 divided by 1/2. Whenever we're looking at a division problem, especially with fractions, we want to know how many sets of something are in something else. In this case, how many sets of 1/2 are in 2/3. Now, most of you have probably heard of the rule for division, which is keep the first, flip the second, and multiply. This is a rule that teachers often use with students, but we don't always explain how it works or why it works. We just tell you that it does. So one of the things that we are going to do today is we're going to look at why this rule works. Let's start with a couple of ways that we can solve this problem if we don't actually remember that rule of keeping the first, flipping the second, and then multiplying. One thing that we can do is we can find common denominators. So here we have a 3 and a 2, and I want a common denominator for those two numbers. Now, since 2 won't actually go into 3 evenly, another quick way to find a common denominator is just to multiply the numbers together. So if we take 2 times 3, we'll get 6, which can be our new denominator. So let's apply that to both of our fractions. We're going to have 2/3, and I'm going to multiply both halves, the numerator and the denominator, by 2 to get 4/6. Then I'm going to take my 1/2, and this time I'm going to multiply by 3 to get 6. And my final fraction there will be 3/6. And so 2/3 and 4/6 are equivalent fractions, and 1/2 and 3/6 are equivalent fractions. Now, once again, our question is how many sets of 3/6 are in 4/6? Let's start by drawing a picture. Since my denominator is 6, I'm going to go ahead and break my picture up into 6 equal pieces. And I usually start in the middle because I have a little bit easier time finding the equal pieces if I break my picture in half first. So now I have 6 equal pieces. Since we are starting with 4/6, that's how many of these pieces I'm going to shade in. So here's 1, 2, 3, 4. Now, since we do have a common denominator, we can actually simplify our question down a little bit. Our question was how many sets of 3/6 are in 4/6? Now we want to look at how many 3's are in 4 since that number is the same. I'm going to switch colors again here real quick. So how many sets of 3 are in 4? Well, right here is our first set of 3. I'm going to just cross shade that a little bit to make it easier to see. So there's our first set of 3. So we have a total of 1 set of 3 so far. Now we have this area right here that is left over that's not going to make a set of 3. Okay, so this one little piece that we have left, let's figure out what it represents. Now, since we've already had this third right here, let's actually think about just what is left of the entire 6. Now, of the entire 6, we have this left. And if you notice, it's broken up into 1, 2, 3 parts. So of the 3 parts that we have left, 1 is still shaded in. So our answer is the 1 full 3/6 that we were able to fit, and then the 1/3 is left over. Since we have 3 total pieces left, we're going to look at just this one piece that's shaded in. For some of you, the picture makes a lot of sense, but for others of you, it gets a little bit confusing. Whereas the addition, subtraction, and multiplication pictures were all pretty straightforward, division pictures, you kind of have to know the rules a little bit before you can understand how they work. And so for many of you, the algorithm is actually going to make more sense when you remember the rule. So let's look at that same problem again with the algorithm. We're going to keep the first fraction, okay? Remember we had keep, flip, and then multiply. So we're going to keep the first fraction. We're going to take that half and we are going to flip it over. When we flip that 1/2 over and turn it into 2/1, we're actually finding the reciprocal of the number. Anytime we are turning a fraction over without changing the numbers, it's just called the reciprocal. Now, so we're keeping the first, flipping the second, and multiplying. So let's see what happens. 2 times 2 is 4, 3 times 1 is 3, and we need to simplify this. So we take and say, well, 3 goes into 4 one whole time, and how many are left over? We have 1/3. Remember, our denominator does not change when we find our remainder. So just like in the picture, you saw that there was 1 and then 1/3. Here we have 1 and 1/3 using the algorithm. Okay, so we know the rule. Keep the first fraction, flip the second fraction, multiply by the reciprocal. All right. Other terms you might hear for this is invert and multiply. So you're inverting or flipping that second fraction. But why does this rule work? What makes it so that it makes any sense? Because it's kind of counterintuitive to actually flip that second fraction over and multiply. Let's think about multiplication and division for just a minute. Multiplication and division are inverse operations. Now, if you remember that word inverse from previous years, inverse means opposite. So multiplication will undo division, and division will undo multiplication. But we're not going to leave it quite there. We're actually going to do some problems and start thinking about, why does this work? What is it that makes it possible? To start looking at this, why does this work? I actually want to start by using a whole number divided by a fraction. So if we have 3 divided by half, what are we going to get? Now we can think of this in a context of how many servings of 1/2 are in 3 containers. Let's go ahead and draw a picture of those 3 containers. There's 1, 2, 3. Now, if we want to know how many servings of half are in these containers, we have to actually break these containers in half. So I'm going to break it in half here, here, and here. Now, I have 1, 2, 3, 4, 5, 6 servings of half in the 3 containers. So let's actually now follow a rule. If we have 3 as our whole number, we can actually turn that into a fraction to make it a little bit easier to work with if we need to. But right now, I'm just going to leave it as it is. So I have my 3, and I'm going to multiply by the reciprocal of 1/2. So I'm going to multiply it by 2 over 1. Now, anytime I have a number like 2 over 1 in the denominator's place, I know that this number right here, the 2, is going to be a whole number now. Okay, so what I'm really saying is that this is 3 times 2, which is going to equal 6. And that 6 matches the picture that we just drew using the containers. Now I want you to look right back over here at our original problem. We have the 3 and we have the 2. Now, if we really were multiplying them, it's just multiplying the bottom number times the top number, because we can take that 3 and we can put it over 1 also. Now if we went 1 times 1, that would give us 6 over 1, and like we said before, that 1 just means that the number on top is a whole number. Our answer for this particular problem is going to be 6. Let's try another one. Say this time we have 5 containers, and I want to know how many servings of 1/4 I can fit or get out of 5 containers. So I'm going to draw my pictures down here again. 5 containers. Now, remember back when we were doing the multiplication, we said that we wanted the lines all to go the same way for each individual fraction. Now, for my 1/4, I want all the lines to continue to go the same way, and you'll see later why this is important when we actually use a fraction divided by a fraction. So here we have containers, and they are each broken up into fourths. Now if I count my fourths, I will find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I now have 20 servings of 1/4 from those 5 containers. So 5 divided by 1/4 equals 20. Now remember last time how we looked at the 3 and the 2? Here we have 5 and 4. And we know that 5 times 4 equals 20. So if we were actually going to work this problem out by multiplying by the reciprocal, we'd have 5 times 4 over 1. 5 times 4 is 20 over 1, and we know that that gives us a whole number of 20 anytime a number is over 1. Now I want you to take a minute and try this next problem yourself. We're going to stick with the whole number. We have 6 divided by 1/3. So take a minute, pause the video, and see what you come up with yourself by drawing a picture and figuring out how many servings of 1/3 are in 6 containers. All right, so if you went ahead and drew your picture, you should have found that there were 18 servings in the 6 containers if we have 1/3 of a container as the serving. Now, once again, you'll notice the 6 and the 3. 6 times 3 gives us 18. All right, let's try one more. I'm going to have you practice 8 divided by 1/5. So this is asking how many servings of 1/5 can be found in 8 containers. Go ahead and pause the video again and try this one yourself. All right, so this time you should have found that there were 40 servings in the 8 containers if each serving is 1/5 of a container. So and again, 8 times 5 equals 40. So you can start to see how multiplying the whole number by the number that is on the bottom is going to give us our answer, our whole number, but in each case the numerator has been 1. What happens if we take the numerator and actually use a larger whole number on it? So if, for instance, we have 5 containers and 3/4 of a container is now the serving. This time our picture gets a little bit trickier, but it is still possible. So I'm going to go ahead and draw my 5 containers. Remember, our question is, how many servings of 3/4 can be found in the 5 containers? Since 4 is our denominator, we want to make sure that each of these containers is broken up into 4 pieces to start with. So here's 4 there, 4 there. Okay, each of the containers is now broken up into 4 pieces. I'm going to switch colors to help illustrate what is going to happen here. Now, since I need 3/4 as a serving, I'm going to go ahead and I'm going to find groups of 3/4. So here's one group of 3/4, 2, 3, 4, 5. So far I have 5 groups of 3/4, but on each of these containers I still have 1/4 that hasn't been used yet. Now I can take along the bottom of these containers and I can make another group of 3/4. And actually let's change this color again to make it a little bit easier to see. So here I have a 6th group of 3/4. So how many full servings of 3/4 do I have? I have 6 full servings. Now, how much is left? Well, since I have 2 left over here, and I'm trying to put things in groups of 3, 3 is going to become my new denominator. And since there's 2 left over, I have 2/3. So let's look at this algebraically and see if it works or not. So this says we have 6 and 2/3 left because we have this and this that we didn't fit in a group, and once again we're trying to make groups of 3 out of these containers because our serving size is 3/4. Now, if we go back to our original problem, we have 5, and I'm going to go ahead and put it over the 1 right now to illustrate a point. And we're going to flip our second fraction, and we're going to have 4/3, and we're going to change to multiplying. So instead of saying 5 divided by 3/4, we're really going to say 5 ones multiplied by 4/3. Well, 5 times 4 is going to give us 20. 1 times 3 is going to give us 3. So now you can see a little bit better where that 3 that we got for our denominator came from. Remember above I said we're trying to get groups of 3, and that's why we ended up with that 3. Well, here you can see that it works out if we follow the rule as well. Now, this is an improper fraction, so we want to simplify. And I'm going to take and I'm going to tip my fraction over. 20 divided by 3, because remember a fraction bar is also a division bar. So 20 divided by 3 goes in 6 times, which gives us 18. And then 20 minus 18 gives us a remainder of 2. That remainder always goes back over our denominator and becomes our numerator. So 2/3 is the fraction. Now you can see that 6 2/3 we came to by either method. Let's try another one, because remember a rule is defined by the fact that it works no matter what the circumstances. So this time let's have 6 containers that 2/3 of the container is a serving. So once again, what we're trying to find is how many servings of 2/3 are in 6 containers. I'm going to go ahead and draw my 6 containers. 1, 2, 3, 4, 5, 6. And since my denominator in my original problem is 3, that tells me how many pieces I need to break each container up into. So the goal is to have 3 equal sections in each of these 6 containers. I'm going to switch colors here for shading to help us see what's going on. Alright, so now I have to figure out how many servings of 2/3 are in the container. Since I've broken it up into thirds, I can find 2 very easily. There's 2 there, 2 there, 2 there, 2 there, 2, 2. All right, because 2/3 is we're finding groups of 2. How many 2's in 3? Now, once again, I have all these left over at the bottom. So I want to turn them into groups of 2 also. And I'm going to switch colors just slightly so that we can tell the difference between our 2's above and our 2's below. So here is a group of 2. Here's a group of 2. And here's a group of 2. Now this one came out nice and even for us. So how many total groups of 2 did we end up with in our picture? Let's do this real quick. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Our answer becomes 9. 6 divided by 2/3 equals 9. Let's take a look at it algebraically. So I'm going to put the 6 over 1 just like I did with the 5 in the last problem. And since the rule says multiply by the reciprocal, I'm going to take the 3 and put it over the 2 and now multiply these across. Now, let's switch colors again here real quick. Remember back in multiplying we talked about cross-canceling when we have numbers that can go into each other. Well, here we have a 6 and a 2, so I'm actually going to cross-cancel those. 2 goes into 6 3 times, so I'm left with a 3 up there and 1 time down here. So now my new multiplication is 3 over 1 times 3 over 1. 3 times 3 is going to give us 9. 1 times 1 is going to give us 1. Now, if you have trouble seeing that cross-canceling, it's okay if you just go ahead and multiply the 6 times the 3. If you multiply the 6 times the 3, you're going to get your 18. 1 times 2 is 2, and these are equivalent fractions. 9 and 18 and 1 and 2. This fraction here is just twice the size of the 9 over 1. And since 1 is a denominator, that just means that we have a whole number, that 9 is our whole number right here. Alright, one last example of why this whole thing works. This time we're going to try 8 divided by 2/5. Now I'd like you to pause the video right here and try this one yourself before we do it together. Okay, so our question is asking how many servings of 2/5 can be found in 8 containers? I'm going to draw my 8 containers and break each of them into 5 pieces. Once again, I want 5 pieces because 5 is my denominator right now. 2, 3, 4, 5, 6, 7, 8. So each of these 8 containers we want broken up into 5 pieces. And remember, we are trying to get pieces as equal as possible. Sometimes it's hard when you're trying to draw fractions, but anytime we're using a picture to represent something, we do want it to be as equitable as we can. So try your best to make even pieces, but if you can't, that's okay too. Sometimes we just run out of room when we're trying to put all the lines in. Okay, so here are the 8 containers that are each broken up into 5 pieces. Now, each serving is 2/5. And I'm going to do this with a couple of different colors. That way we can see them a little bit better. Let's start here. So, across the top of each of these, we have a serving of 2/5. There we go. Get the whole box in. So far, we have 8 servings of 2/5. However, you'll notice that there are more fifths left over here on the bottom than what we've had before. So I'm going to switch colors again to make it easy for us to see where our next set of 2/5 is. And it's actually going to be right under that top one. So we're going to have 8 more sections of 2/5 from each of our 8 containers, which means that in the 8 containers we have 16 whole sections of 2/5. Lastly, we have those sections at the bottom that did not fit into 2/5, but we can still group together. And so trying to make groups of 2, here's 1, 2, 3, and 4. So how many total groups did this turn out? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 8 divided by 2/5 equals 20. Let's take a look at the algebra again. I'm going to go ahead and put that 8 over 1, just like I did with the other problems, to turn it into a fraction, but that 1 just means that we have a whole number 8. And since I'm multiplying by the reciprocal, like the rule says, my 5 is now going to be my numerator, and the 2 is going to be the denominator. 8 times 5 is going to give us 40, and 1 times 2 is going to give us 2. Now I kind of put that off to the side over there because I want to go back and look at this using our cross-canceling again. 8 and 2 are both even numbers, which means that I can make each of them smaller. 2 is going to go into each of these numbers. It goes into 8 4 times, and it goes into 2 once. So my new fractions are 4 over 1 times 5 over 1. 4 times 5 is 20 over 1, which really means that we have a whole number 20. And you can see 20 over 1 and 40 over 2 are equivalent fractions because both the 20 and the 1 can be multiplied by 2 to get 40 over 2, or 40 halves. So once again, that makes our answer 20. Hopefully this lesson gave you some better insight into why the rule works for dividing fractions. Now, we didn't actually divide a fraction by a fraction in this particular lesson because it is harder to illustrate, but you can think of any whole number as a fraction by just putting it over 1. So if you look at our algebra that we did in each one, we were taking a fraction divided by a fraction. So if you can always remember that you're trying to break one number up into how many servings, it kind of will help you to remember what you need to do. If you have any questions, remember to ask your teacher, get things cleared up as best you can, and good luck with dividing fractions.